Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing right-angle trigonometry, the Pythagorean theorem. So in the first question, we are told, calculate the length of AC. So in order to calculate the length of AC, we apply the Pythagorean theorem. The Pythagorean theorem basically says the following. If we have a right-angle triangle, with sides A, B, and C has to be the hypotenuse, which is the longest side. The Pythagorean theorem says that C squared equals A squared plus B squared. Therefore, in order to get the hypotenuse, you'll get C squared equals 2.5 squared plus 4.1 squared. Therefore, C squared is equal to, I'm going to use the calculator to figure this out. So 2.5 squared plus 4.1 squared gives us 23.06. And then in order to get C, we simply find the root of 23.06. And this is equal to 4.8. And that is the length of the hypotenuse AC. And 4.8 is the correct answer here. In the next problem, we are required to find the value of x, but in this case, the x is not the hypotenuse. So there are two ways to do this. The quick way is just to say that x is equal to root of the hypotenuse minus the other side, each of them raised to the power of 2. So this is the quick way of finding x. And let's figure this out on the calculator. So 8 squared minus 5 squared under the root. This is 6.24. If you don't want to memorize how to do this, the slow way of doing it is to call this C, and again to say C squared equals A squared plus B squared. And C is 8, so 8 squared equals 5 squared plus x squared. Therefore, 64 equals 25 plus x squared. And therefore, x squared equals 64 minus 25. So x squared is equal to 41. Therefore, you can get x by finding the square root of 41, which is going to again be 6.4. So you got the same answer, but it took more time. So you can either use this technique or that. Either way, the correct answer is 6.24. So in this problem, we have a more advanced question. We have in the pentagon ABCDE, angle ACB equals angle AED equals 90. Triangle ACD is equilateral with side length 12. DE equals BC equals 6. We are required to calculate angle BAE. So this is angle BAE. Let's split it into three parts, letter A, letter B, and letter C. We can say that angle BAE is equal to A plus B plus C. So let's start with B because it's the easiest of them all. B is an angle in an equilateral triangle here. So therefore, we should know that B is equal to 60 because each angle in an equilateral triangle is equal to 60. Furthermore, we can say that since this is 12, this is also 12, and this is also 12. And then we can proceed to find A and C. So in triangle AED, we have the following information. We have A, E, and D. We have this side equal to 6. We have this side equal to 12. And we want to get letter A here. And this is the 90-degree angle. So you need to figure out what is the opposite, what is the adjacent, and what is the hypotenuse. Of course, this is the opposite here. And this is the adjacent, and this is the hypotenuse. So we have O and H. So we're going to use SOH. Sine A equals opposite over hypotenuse. So A is equal to inverse sine or shift sign on the calculator, 6/12. And this is equal to 30. So A is equal to 30. And then finally, we want to get C. So let's use the triangle in which C belongs, triangle ABC. So triangle ABC looks something like this. This side here is 6, and this side here is 12. This angle is C. Again, we need to label the sides. So this would be the opposite, this would be the adjacent, and this would be the hypotenuse, because the hypotenuse has to be the longest side. So we have opposite and adjacent, so we can use TOA. So tan C equals opposite over adjacent. Again, C would be inverse tan of 6/12. And you can use your calculator for that. This would give us 26.6. And you can just plug it into the equation above. So we have here 26.6. And then you can use your calculator to figure out the big angle BAE. So 30 plus 60 plus 26.6 gives us 116.6. Or 117, that would work as well. So let's check the marking scheme. So 116.6 is the correct answer. Next, they want to calculate AB. So in order to calculate AB, we simply go back to the triangle that has AB. We are looking to find the hypotenuse. So we can use the Pythagorean theorem as we said before. So AB is equal to root of 12 squared plus 6 squared. And we can use the calculator to figure this out. So root of 12 squared plus 6 squared gives us 13.4. Next, we want to find AE. So let's go to the triangle that has AE. And we want to find the third side in that triangle, which is the adjacent. So let's call this X. We can say that X is equal to root of 12 squared minus 6 squared, because it's not the hypotenuse, so we use minus instead of plus. So root of 12 squared minus 6 squared gives us 10.4. Therefore, the side AE is 10.4. So let's just write the answers down. Angle BAE is 116.6. Side AB is 13.4. Side AE is 10.4. Finally, we want to calculate the area of the pentagon. The pentagon is the whole shape. So to calculate the area of this entire black shape, we need to calculate the three areas of the three triangles. So the area will be area of triangle AED plus area of triangle ADC plus area of triangle ACB. So for the right angle triangles, you can use the rule that says area equals half base times height. But for the triangle in the middle, we have to use half AB sine theta in order to find the area. So in the first triangle, AED, we said that the base AE is 10.4. So we write half times 10.4 multiplied by the height, which is 6. For half AB sine theta, the two sides are 12. So we just write half times 12 times 12 times sine B, which is sine 60. And finally, for the third triangle, we use half times base times height again. This time, we're talking about triangle ACB at the bottom. So the base is 12 and the height is 6. So half times 12 times 6 should be okay. And we calculate each of these, or you can write it on the calculator in one shot and get the final area. So the final area will be the following: 0.5 times 10.4 times 6. And then you add to that 0.5 times 12 times 12 times sine 60. And then you add to that 0.5 times 12 times 6. You should get a total area of 129.55. And this would be the final answer. Let's check the marking scheme. So 129.55 is correct, 10.4 is correct, 13.4 is correct, and 16.6 is also correct. For the final question in this video, we have triangle EFG has an area of 70 meters squared. EF to FG is 1 to 2, and angle EFG is 40. Calculate EF. So how do we calculate EF? Let's draw the triangle first. We have triangle EFG like this. And the ratio between EF and FG is 1 to 2. So EF to FG equals 1 to 2. Let's call this x. This will be 2x. So let's write down x and 2x here. And the angle EFG is 40. So the area of the triangle would be half AB sine theta. So half times x times 2x times sine 40. And that is equal to the area. So we have half and 2, they cancel out. So we have x squared times sine 40. Sine 40 is equal to 0.64278. Excuse me, this is x squared multiplied by 0.64278. And this is equal to the area. And we are already told that the area is 70. So we can divide 70 by 0.64278. And that gives us x squared, which is EF. So let's calculate that using the calculator. So 70 divided 0.64278 gives us 108.9. So x squared equals 108.9. Therefore, we take the square root to find x. So square root of 108.9 is equal to 10.4. And that would be the final answer to question I. For question II, it says a different triangle PQR also has an area of 70. PQ to QR is 1 to 2, and PQ to EF, PQ equals EF. Find angle PQR. So let's draw the triangle again. We have PQR. We are told that the ratio of PQ to QR is 1 to 2. So we can say that this is x and this is 2x, same idea as last time. And we are told that PQ is equal to EF. Now, since we know that PQ is equal to EF and we know EF is 10.4, so we can simply just put 10.4 here and we multiply it by 2, so that becomes 20.8 on this side. And this angle here, PQR, is the unknown, so let's write theta. So the area would be half times 10.4 times 20.8 times sine theta. Now the area is 70, so 70 equals, and then we multiply 0.5 times 10.4 times 20.8. That gives us 108.16 times sine theta. So to get sine theta, we divide 70 by 108.16. And then instead of writing it down, I'm just going to write shift sign on the calculator, inverse sign, I'm going to write the answer. So inverse sign this fraction, gives us theta equals 40.33. If you want to write it in one step, you can just write shift sign 70 divided 108.16, and that should give you the correct value of theta. But the problem here is that if we use theta equals 40, what happens is it becomes the exact same triangle, because now we have, again, triangle 10.4, 20.8, and angle 40 point whatever. So it's the exact same triangle, but they have here a different triangle. So the idea is that instead of using the 40, you have to apply the asterisk rule, and you have to realize that for sine theta to be equal to this number, theta can either be 40, which is this quadrant here, or it can be also 180 minus 40. So therefore, the correct value of theta here would be 180 minus 40, which is 140, in order to give us a different triangle. So therefore, theta equals 140 degrees. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.